The other thing I want to say, though, is that there's a cup pairing. Complex coefficients, which, of course, after evaluation on the fundamental class, takes you to the complex numbers. And this is, what you do is you can think of this, there's a chain, there's a section, and you're going to cup another chain with another section. What you do is you cup the chain part, and then you stick the sections into the killing form. Okay? And this induces a symplectic structure on the character variety sigma g with coefficients in g. That defines a closed non-degenerate form on the irreducible representations. And this chain complex, this is a symplectic chain complex because the boundary operators act as a derivation with respect to the cup pairing. And then there's a theorem, a theorem of Witten that says the Reidemeister torsion is symplectic volume. So in fact, and this is just follows from the algebra of the fact that you're calculating Reidemeister torsion here, and the boundary operators act as derivations. You just write this stuff down, and that forces this to be the symplectic volume. And so the Reidemeister torsion necessarily shows up when you quantize, and that's why it's in over 4, because it's the symplectic volume.
But this is all torsion on this two manifold, right?
This is actually torsion on the character variety. But
I mean, the torsion you're referring to, I thought you said was torsion of the representation at rho.
At rho, but that's the tangential complex.
Sure, but if this is at rho is a local system on sigma g.
Right, so that's a tangent space at one point.
No, I understand, that's right. But then you're taking the torsion of the complex, computing the cohomology of that local system on sigma j, right?
Yes. And that computes the tangent space, at least when you're at an irreducible representation. And then that volume you get from torsion is the symplectic volume on the character variety that comes from this symplectic pairing.
For a surface.
For a surface. Okay.
But is this related to Reidemeister torsion on 3 manifolds?
Yes, it is. It shows up because you see a 3-manifold can be represented by a Heegard splitting, and that gives rise to a complex. And so there's a formula for the Reidemeister torsion of the representation of 3-manifold that involves the Reidemeister torsion of the 2-manifold. And so once again, there's this paper, a geometric Casson invariant from, and it never got published. Which was by Dennis Johnson. And he wrote it about 1983, where he basically all these quantities that anybody's writing down, they appear in those notes, and the relationships between them are worked out. And I'm pretty sure a lot of people have copies of the notes. For instance, he defined the signed refinement of Reidemeister torsion. That's where they were done, in that notes, and then that later appeared in other things. And in fact, the chain complexes that Cordy looks at appear in the last section of that paper. So
I just want to understand one thing. So you have the symplectic volume associated with the character variety.
yeah.
Associated with the surface. And for some particularly, but to define the volume that you're talking about, you picked a particular row, is that right?
I'm defining the volume form on the tangent space at that particular representation. So the character variety is made up of
Right.
equivalence classes of
But does the
representations.
volume may depend on that choice? Does it depend on the
Oh,
choice?
of course, there's no way of
Yeah, yeah.
comparing.
Of course, it depends on that.
Right, but this is, but they woven together, that's the volume form on the manifold. You weave-
Right.
This is the,
But I guess my question was this: I can see why this would appear in quantization of the transcendent theory, because
Yes.
this character variety essentially is the classical phase space for
Right.
the transcendent theory. So quantization of that will give you will involve the volume of that classical phase space. But you're saying that right-dimensional torsion is also directly related to the right-dimensional torsion of the three manifold of which this is a boundary.
right. So there's a paper of mine and Joanna Kanya Bartoshinska from 2013 that's in quantum topology, where we give an explicit, so we integrate the Dubois torsion over components of the character variety, and we give an explicit formula for it. And in fact, the thing that defines the Reidemeister torsion of the surface appears in it. What we get is the heat kernel regularization of the Turaev-Viro invariant is what we get. But what's funny is when you do it from this viewpoint, that appears, but when you do it from the quantized guys, it doesn't appear in the formula. And what has to be happening is the torsion of the surface is lurking in the formulas for the quantum 6J symbols and the other things, the 3J symbols. All right, I'm off the hook.
Okay.